Welcomes all of you. In this video session, we will see the Cathodic protection, the principle, and the two different methods. The first one is the sacrificial anode method, and the second one is the impressed current method. Their process, their applications, and the limitation. So let's begin with our topic, that is Cathodic protection. The principle of Cathodic protection is metal to be protected is forced to behave as a cathode. On that principle, Cathodic protection is work. Right? What is the principle of Cathodic protection? Principle of this method is the metal to be protected is forced to behave as a cathode. Right? And there are two different ways for doing the Cathodic protection. The number one method is sacrificial anode method, using sacrificial anode method, and the second one is using impressed current method. So the first method we will see, that is sacrificial anode method. See, this is the simple diagrammatic representation, that is Cathodic protection using sacrificial anode method. Okay, here is the underground pipeline, right? And that underground pipeline is connected with the help of insulating wire to what? Anode. And anode is what? Pure plate of metal, that is aluminum, magnesium, zinc or their alloy, which is kept into what? Wet soil, and which is the anode is also kept in what? Backfill. Backfill, mostly it containing coal or NaCl. It can increase the electrical conductivity, right? This is a simple diagrammatic representation. Now the method is very simple. The metallic structure, right? The metallic structure to be protected from corrosion is connected to what? Anodic metal. The anodic metal, which is very active, right? And that is connected with the help of what? Insulating wire, right? The more active metal, which is the more active metal? Aluminum, magnesium, zinc, right? Act as an anode, and anode itself get corroded, but it remain protected the main metal surface. Hence it is called as what? Sacrificial anode method. Means anode itself get corroded, but your main metal surface remains from the protection. So this is called as what? Sacrificial anode. For this purpose, electrical conducting environment can be increased while your active metal is placed in what? Backfill. What is the backfill? Backfill containing what? Coal or NaCl, right? Now, what is the application of sacrificial anode method? The application of the sacrificial anode method is, this method is useful for the protection of what? Burn steel pipelines, right? It is useful for the ship hull, right? It is also useful for the protection of hot water tank. It is also useful for the protection of the burn cables and wires, right? Again, this method is also useful for magnesium or zinc rod bolted along the side of the ship, right? The zinc rod are inserted into the boiler or hot water tank to prevent from the corrosion. And this protection, which is going to take place what? At underground level. See, here it is clearly indicated that this type of protection, it can be carried out at underground level. So this is your what? Sacrificial anode method. Cathodic protection using sacrificial anode method. Now the second type of method is cathodic protection using impressed current method. Now here is again a simple diagrammatic representation is there. In this case, the underground pipeline, which is act as a cathode, which is connected with the help of what? Insulating wire into what? Your graphite or stainless steel sheet. This graphite or stainless steel sheet, which is kept into what? backfill. Again the backfill is nothing but what? Coal or NaCl, right? So this is what your the impress current method. In this method, impress current is applied in opposite direction. Here is what? Impress current is applied in opposite direction to nullify the corrosion current and convert the corroding metal from anode to cathode, right? Convert the metal from what? Your anode to cathode. The impress current is derived from what? Your DC source, right? And which is given into insoluble anode like, which is the anode? Graphite, right? Or stainless steel, or a scrap of iron, which is kept in what? Soil, which is act as what? Anode. The negative terminal of the pipeline, this is the negative terminal of the pipeline, is connected to what? Your pipeline, right? The negative terminal of the DC source, which is connected to pipeline, and positive terminal of the DC source, which is connected to what? Your graphite, right? Then which is graphite, which is also kept in what? The backfill, in order to increase the electrical surrounding environment, right? This is the simple method of impress current method. The application of this impress current method is this type of cathodic protection, which is mostly applicable for protecting the open water box cooler, right? Again, it is useful for the protection of the water tank, right? Means water tank which is made up from the steel or stainless steel, right? Burn water or gas pipeline. It is also useful for protection of the condenser, transmission line tower, right? Then marine piers. For the protection, this type of method which is particularly used, right? And only the limitation of this method is the investment, means high capital investment and maintenance cost is very high. This limitation of this impress current method is the high capital investment and maintenance cost is very high. And because of the stray current, a pipeline or metallic installation nearby protected metallic structure, it gets corroded rapidly, right? And special care we have to take to see the structure is not over protected. Otherwise, problem is associated with what? H2 liberation and OH minus formation, right? So this is called as what? Limitations of your impress current method, right? I will again highlight the previous point. What is the principle of cathodic protection? Principle of cathodic protection is the metal to be protected is forced to behave as a cathode. Is called as what? Cathodic protection. There are two different ways for doing the cathodic protection, using sacrificial anode and using impress current method. So what is the sacrificial anode method, right? In the sacrificial anode method, the metallic structure to be protected from the corrosion. See, this is the metallic structure which is protected from the corrosion is connected to what? Anodic metal, right? With the help of what? Insulating wire. See, this is the insulating wire. And anode is what? Anode is the more active metal. Which is the more active metal? Aluminum, magnesium, zinc, right? And which is act as what? Anode. Anode itself gets corroded and your metal protected from the corrosion. Hence it is called as what? Sacrificial anode method, right? And for the purpose of the electrical conductivity increase, we are going to step the anode into the backfill, which is the backfill coal and NaCl, right? So due to this, it can increase the electrical conductivity. And the application of the sacrificial anode method is what? It is useful to protect the burn steel pipeline, ship hull, hot water tank, burn cables and wire. It can be protected with the help of what? Sacrificial anode method. The second one is what? Your impress current method. In this method, impress current is applied in what? Opposite direction to nullify the corrosion current and convert the corroding metal from what? Your anode to cathode, right? Corroding metal we have to convert it into anode to cathode. So the impress current is derived from what? DC source, and which is given to what? Insoluble anode. Which is the insoluble anode? It likes what? Your graphite, stainless steel, or scrap of iron, which is act as what? Anode. And the negative terminal of the DC source, which is connected to what? Pipeline. The positive terminal of the DC source, which is connected to what? Graphite or stainless steel, right? Then the anode is kept in what? Backfill. So this graphite or stainless steel, which is kept into what? Backfill, mostly cold or NaCl, in order to increase the electrical surrounding environment, right? And the application of this method is, this type of cathodic protection is applicable for protection of what? Open water box cooler, water tank, burned water or gas pipeline protection, condenser protection, transmission line tower, right? So these are the preventive method which is useful for what? Control the corrosion. I hope that you understood the concept of cathodic protection. Okay, if you have any doubt regarding to this, you may post your queries on what? Discussion forum, right? Thank you very much.